Hello, welcome. Today we're going to talk about max Born probability density. And this is the one a very difficult concept when any student try to learn quantum mechanics. Because it's conceptually it's harder. You have two words there. One is a probability, one is density. And so we are going to use 3 videos to explain this idea. And each of these video probably takes about 5 minutes, something like that. So let's get started. First, the max Born probability is a density. So therefore it has units. If you have just one-dimensional, there'll be 1 over meter. If you have 2-dimensional, there'll be just area, 1 over meter squared. 3-dimensional, 1 over cubic meter. That means the density. If you only have the probability, then you do not have units. Probability is just a percentage over something. So the first video, I'm going to show you real basic. First, the units that I already explained here. Next, let's look at the definition. So here's the definition. Quantum mechanics assumes that probability density equals the module of the wave function. The reason we take module is normally wave function is a complex number. We have to take its module. So it's essentially a square complex conjugation of that. And it's dependent on the position, which we usually use letter R to representing that. T is the time. So the coordinate that I want to show you is the following. Here is my x-axis, here is my y-axis, and here is my z-axis. Now, if you are interested in the point, let's say R, at the location R, so then at this particular point, then I have a wave function. So amount how large the wave function that is. So therefore my R is the coordinate, T is the time, my psi is the wave function. Because the probability density has units as I just mentioned, so therefore the wave function must have the units should be square root of the probability density units. So that's why I can see 1 over square root meter and 1 over square root meter squared and 1 over square root cubic meter. Let's look at the single electron. If you do the integral over entire space, this is the over entire space, so essentially entire space, then the maximum probability you will get 100% or 1 here. If your integration is over entire space, and this is also called normalization condition. Normalization is the mathematical terminology. It just in physics just means 1 equals 1. So that is why it's called a normalization. If you have 1 electron, if you integral over the space, and then it just equals 1. Now you see here, I do not have units anymore because the density I already take integral over the volume part. So therefore, these 2 units cancels out. So essentially, this particular part, the integration of the probability density gave you the probability. So this 1 is really the probability. It has no unit. If you have more than 1 electron, suppose you have n number of electrons, so then you will end up with the integration over n. And this is again also called normalization. Now, in case if your integral is not over the space, a limited space or restricted space, same integral, then this must be less than 1 if you have 1 or less 1 particle. Now you see the probability makes sense. We cannot say really number now because you are doing a restricted integral. So therefore, the number of electrons is less. Maybe have 50% or 10%, or it could be 0% if electron never appears in that particular region. Now let's look at a little closer. So here is a summary. Rho itself is called probability at point R, T. If you multiply by the dr, this particular term is called a probability. Now, probability within the volume, so which we are going to say within the volume dr, like this, within the volume dr. It has no unit, it has a unit. So that's why this is called probability itself. When you do the integral, you are integral over one particular region, so that's called probability. So probability depends how your integral looks like. And this is my first video.